So welcome students. In the last video we have learned that if you introduce a dielectric in between the plates of a parallel plate capacitor, the capacitance will be equal to epsilon 0 A into D minus T plus K, or that can be written as this way also. Okay. Now we have learned a special case when T is equal to D, that is entire capacitance is entire space between the parallel plate is filled with the dielectric. You got it as epsilon 0 Ka by D, that also you got. Now let us learn another special case where in the parallel plate capacitor you are filling it with the different dielectrics. You are filling it with the different dielectrics of different thickness, let it be T1, and its dielectric constant is K1. This is another dielectric of thickness T2, dielectric constant is K2. This is another dielectric with the thickness T3 and dielectric constant K3. And this is another dielectric with the T4 and dielectric constant K4. Like that, imagine there are a number of plates and there are different types of dielectrics introduced between the entire thickness of the in between the parallel plates. Okay, let us see what will be the case. We will apply that formula here. So we have C is equal to epsilon 0 A by D minus T into plus T by K. So in this case this formula will become like this. C will be equal to epsilon 0 A, there is no change in epsilon 0 and A, and D is also, this is the thickness, total thickness is D, and D is equal to T1 plus T2 plus T3 plus T4. So instead of here I have to write D minus, what is T? T is T1, T is the thickness of the dielectric, total dielectric. So it is T1 plus T2 plus T3 plus T4, T1 plus T2 plus T3 plus T4 plus, here there is not, here there are 4 dielectrics or any number, n dielectrics, you imagine like that. Then here this term will become T1 by K1 plus T2 by K2 plus T2 by K3 plus T2 by T3 by K3, T4 by K4. In this case I am taking only 4. If it is n type, it will go like this. Okay. Now, C will be equal to epsilon 0 A by, what is D minus T1 plus T2 plus T3 plus T4? That is D. That is D minus D plus T1 by K1 plus T2 by K2 plus T3 by K3 plus T4 by K4. So this will become 0. So C will be equal to epsilon 0 A by T1 by K1 plus T2 by K2 plus T3 by K3 plus T4 by K4. If there are n slabs, T1, T2, T3, T4 like that, then this will go on like this. Okay. So this is the capacitance of a capacitor if you have different dielectrics of different thickness and different dielectric constant. It will be epsilon 0 A by T1 by K1 plus T2 by K2 plus T3 by K3 plus T4 by K4, like that it goes. Okay. So if there are number of dielectrics, then C will be equal to epsilon 0 A by T1 by K1 plus T2 by K2 plus T3 by K3, like that it follows, plus Tn by Kn. This is another formula. Now let us move to a capacitance of a parallel plate capacitor is 50 picofarad, and the distance between the plates is 4 millimeter. D is equal to 4 millimeter. Capacitance is 50 picofarad. It is charged with a 200 volt, and the charging battery is removed. Now a dielectric slab of dielectric constant 4 and thickness 2 millimeter are introduced between the plates. Find 1. The final charge on each plate. 2. The potential difference between the plates. 3. Final energy of the capacitor. Energy loss, if any. If there is an energy loss, how much energy is lost? See, the question is this: there was a parallel plate capacitor, and this is being charged by a battery. The capacity is 50 picofarad, and the potential of this battery is 200 volt. You have connected both the plates, and it has become plus, positively charged plate here, negatively charged plate, and now the battery is removed. After charging, the battery is removed, so this capacitor will contain this much charge. Sorry. Now after that, one dielectric slab is introduced in between them, of how much thickness? 2 millimeter thickness. This is of 4 millimeter, this is 4 millimeter, and this is 2 millimeter. Now when a dielectric is introduced, what will happen? Its capacitance will change. So now the capacitance has changed. So what is the question? Question is final charge on each plate. Final charge on each plate won't change, because if you introduce a dielectric between, the charge will remain constant. The charge stored in the capacitor will remain constant. What will differ? The potential difference will differ, because when you introduce a dielectric, the capacitance changes, and C is equal to Q is equal to C into V. So when C changes, Q remains constant, V will also change. Okay, now let us see what are the data given, then we will do this problem. Okay, and we have to find out there is a energy loss in that final energy of the capacitor, and energy loss, if any, whether there will be a change in energy. First we have to do it, think of that. Then we have to find out if there is a change in energy carried by the capacitor. Then what we have to find out? We have to find out how much energy is lost, and what happens to that energy. If there is a loss, what happens to that energy? That is also one interesting thing. So let us do the problem. That capacitance, initial capacitance let it be Z0 is equal to 50 pf, that is 50 into 10 raised to minus 12 farad. Then thickness or separation, D is equal to 4 millimeter, that 4 into 10 raised to minus 3 meter. Now potential difference V0, initial potential is V0, potential. V0 is equal to 200 volt. Now, thickness of dielectric T is equal to 2 into 2 millimeter, that is 2 into 10 raised to minus 3 meter. This is the data given. Now, let us find out the charge. See, the charge won't change. When you introduce a dielectric, the charge won't change. So, let us find out what is the charge in the capacitor when it was initially charged. We have the formula Q is equal to C into V. Here, therefore, charge Q. I am taking small q here, no matter. I will be using capital Q and small q. There is no difference in between them. So, charge Q will be equal to Z0 into V. So, that will be equal to 50 into 10 raised to minus 12 into what is V? 200. That is equal to 10 raised to 200 into 5, 10 raised to minus 4 coulombs. 1, 2, 3, 4. So, 10 raised to minus 8 coulombs. This will be the charge. So, the first answer for the first question is charge Q is equal to 10 raised to minus 8 coulomb. That we got. 10 raised to minus 8 coulomb. That is the answer. Now, let us see what is the potential difference between the plates. Initial potential difference was 200. Now, what is the potential difference between the plates when dielectric is introduced in it? What changes when dielectric is introduced in it? When a dielectric is introduced in a capacitor, the capacitance changes. Let C be the new capacitance. So, we have C is equal to, so before that we will do one thing. Z0, what is Z0? Z0 is equal to epsilon 0 A by D. C0 will be equal to epsilon 0 A by D. Epsilon 0 A by D. And A and D do not change. So, what will be the new capacitance? C will be equal to this formula. Epsilon 0 A by D minus T plus T by K. Then, when a dielectric is placed, what will be Z0 by C? C0 by C will be equal to epsilon 0 A by D divided by epsilon 0 A by D minus T plus T by K. So, that will be equal to D minus T plus T by K divided by D, and that will be equal to, what is D? D is 4 into 10 raised to minus 3. 4 into 10 raised to minus 3 minus 2 into 10 raised to minus 3 plus 2 into 10 raised to minus 3 divided by 4 divided by D. D is 4 into minus 3. and the answer will be, this will be equal to 5 by 8. If you work on this, you will get it as 5 by, end of this bracket. So you will get it as 5 by 8. That you have to keep it in mind. C by Z0. So C0 by C is equal to 5 by 8. Okay. Note down. So now you got the charge as 10 raised to minus 8 coulombs. Now one important thing you have to keep it in mind, that is the capacitance and change, the ratio between the capacitance is 5 by 8. Now the charge in both will be the same. So we have the formula Q is equal to C into V. Q is equal to C into V. So here Q will be equal to C0 into V0, and Q will be equal to C by V. If you divide these two, you will get C0 V0 by CV is equal to 1. And C0 V0 by C is equal to V. Here you have to find out potential difference between the plates V. So V will be equal to C0 by C into V0. The charge is constant here. In both the cases, when you introduce a dielectric, and before introducing the dielectric and after introducing the dielectric, the charge inside the capacitor is same. So that is given by Q. That we know it is 10 raised to minus 8. So we have the formula Q is equal to C into V. So initially it was C0 into V0. Now it has become C into V. We have to find out V. So equating, comparing these two, you will get V will be equal to C0 into V by C, and that will be equal to, what is C0 by C? C0 by C is 5 by 8. 5 by 8 into 200, and that will be equal to 125 volt. So the new potential difference between the plates will be equal to 125 volt. This is the answer. 125 volt. This is the answer of the second question. Okay, please note down. Now let us see what is the energy stored in the capacitor. What is the energy stored in the capacitor? Energy. What is energy? Energy will be equal to, we have the formula, energy is equal to, U is equal to half QV. U0, initial energy, that is energy of the capacitor before we are introducing a dielectric. U0 will be equal to half into Q. Q is 10 raised to minus 8 into V0. That is equal to half into Q is 10 raised to minus 8 into, what is V0? V0 is initial potential into 200 is equal to 10 raised to minus 6 joules into 100, that is 10 raised to minus 6 joules. So it will be 10 raised to minus 6 joules. Now final energy, what will be the final energy? Final energy U will be equal to half into Q into V is equal to half into 10 raised to minus 8 into 125, and that will be equal to 125 62.5 into 10 raised to minus 8, that is equal to 0.625 into 10 raised to minus 6. This will be this much joules. This is the energy the second time. You see how much energy is lost. It was initially it was 10 raised to minus 6. It was reduced to 0.625 into 10 raised to minus 6 joules. So I am deleting this. This. So loss of energy. Will be equal to U0 minus U, and that is equal to 10 raised to minus 6 minus 0.6 into 10 raised to minus 6 is equal to 625. 10 raised to minus 6, that is 1000 minus 625. That will be equal to, and this will be equal to 400 0.375 into 10 raised to minus 6 joules. This is the loss of energy. This much energy is lost during the transit. This much energy is lost. Where that energy has gone? That is the interesting point. See, there was a capacitor and you are charged with 200 volt. The potential difference between the parallel plates is 200 volt. You are simply introducing a dielectric in between them. The energy has come down. Where that energy has gone? What really happens is, when you introduce a dielectric, the capacitor will exert a force on dielectric. So in order to introduce the dielectric inside, we have to apply some force. Okay, so that energy is lost in pushing the dielectric back. So that is what really happens. When you introduce a dielectric, the electric field inside it will exert a force, and energy will be lost by that. Okay, that is how energy is lost. So this is the loss of energy. So here loss of energy is 0, or we can write 3.75 into 10 raised to minus 7 joules. This is the answer. And final energy of the capacitor. Final energy of the capacitor will be 0.625 into 10 raised to minus 6 joules. That is the final energy of the capacitor, and this is the loss of energy.